Happy Tuesday. Oh, yeah. Yeah, it's Tuesday. Okay. I have my echo still on. I should turn that off. Okay, good. I can't hear myself in my face now. All right. Yeah, happy Tuesday. We're back here with some Shenzhen I. We're going to have a blast finishing this thing up. It says the camera's live, but I don't know if you've ever noticed, but nothing's moving. This is the stillest city ever. I mean, there's cars sitting in the middle of the street. What are they doing out there? All right, we need to post this over here. And then we got this new feature on Blue Sky where I can apparently set myself to live. So I can't do that from the web. Okay, let's do that from the app then. Bear with me just one moment while I try out this totally brand new feature. No idea if it's gonna do any good, but you know what? Might as well beta test it while it's there. Go live. Just gotta share. I love typing out links manually. Hooray. Boom, boom. Boom, 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 boom. Yes, we're gonna be live for, I don't know, let's say that long. Go live. Bam. All right, I am now live. People can see that I am live if they use Blue Sky. Does it show up on web at least? Or is it really just internet? Oh, it does show up on web. Cool. All right, cool. So we're getting back in here. We wrapped up. Did we wrap up? Would you believe it? Yeah. We did that. Wow, those are all toughies. All right, we got some spam email there. We got an airline cocktail mixer. I was inspired by a flight I was recently on. Most of the drinking options were whatever the flight attendants could throw together, just a mixer and a small selection of liquors. A drink mixing device could be made in an easily portable case. Hang on. Who are you and what have you done with Joe? Since when? Yeah, I mean, people like to drink. Okay. Keypad is an X-Bus input connected to a keypad. Vodka, gin, lemon, lime, cranberry, and vermouth are simple outputs. That is a lot of outputs, too. When a value is available from the keypad, read it and assemble the corresponding cocktail recipe from the Elegant Bachelor, which can be found in the supplemental data section. So we got 1, 2, 3, 4, 5, 6, 7. That is exactly 14. So I'm thinking we got a ROM chip that we can read from, and then we'll have 2 of these. What are the output names? Let's pull it out just so we can see the name, and if we need space, we'll come on. All right, so that has now reduced us down to 2 inputs to here. We need 2 for this. And we need 1 tied to this. So we're probably looking at a couple of small components. Let's see what the input comes in. Keypad 4. It needs to hold it. There's a timing window on it that we did not have in store. I guess we should look up the data. Let's pop on over here. Contents. Okay, it said to look in the supplemental data. The Elegant Bachelor in the supplemental data. All right, there we go. Wow, look at that. 1.5 ounces of vodka. Wow. Well, this is just lovely. Yes, it is. 'Cause this isn't gonna work, is it? We need different amounts, I guess. So 1.5 ounces of vodka for a vodka shot. Vodka shot is number 1. Do we have any number 1s coming in? We do. 1, 2, 3. Okay, so that is half an ounce delivered. So yeah, we do need to keep that for a certain amount of time, which is gonna be very difficult. Yes, it is. How are we going to store this? I thought we could just encode it into like numbers of, you know, yes, this one. But no, we've got to do output. So we've got 1.5 ounces of vodka, so that's like 3 vodka. Then lemon drop, we've got 3 vodka, which is 6 vodka. And 1 lemon mix. Do we have anything that goes over 9? No, we do not. So theoretically, we could still store it. I mean, we could still store it as 2 digits for each one. So I'm thinking like vodka shot is 3 vodka. So 3 vodka and then 0, right? So that's basically just saying 3 instances of vodka. But then we've got 2 flipping pens per. We've got to decrement this stuff. So we've got to pull the value out, decrement it, and then operate it again. I think maybe we're okay. Can I put this there? Oh, I can. Okay, cool. Let's go with this theory. We're gonna go with this theory. So we'll have a piece here that'll pull data. Let's put some notes out so we don't forget what we're thinking. Like, figure out which one to make send make signal. And then we'll have a piece here. Receives make signal. Signal. Pulls values, sends to senders. Waits for both to return. All right. And then we've got one here. It'll be sending vodka, gin, lemon, and then sends done signal. Because we can't, I mean, we're busy processing. We can't like receive a new signal. Do we have a case where a signal comes in like that? It doesn't look like we do. Seems like it'll work, but so we can probably skip that. Maybe just skip the done signal. So we like skip that, right? And then this is send lime, cranberry, and vermouth. Okay, so our next drink is going to be, are these in order? Yeah, these are in order. Lemon drop, cosmopolitan, Cape Cod, vodka martini, gimlet, and gin martini. Great. So we're just going to enter this data from the sheet over here. I'm going to pause that. I'm like streaming myself. Where did you go? Info sheet. Okay. Lemon drop is 3 vodka. So that's actually 6 and 1 lemon mix. So 1 ounce, right? 1 ounce of lemon mix. So that's actually 2. And then that's it. So it's a 0. Cosmopolitan is 2 ounces of vodka. So that's 4. Lime is on the next one, and cranberry mix. So that's 4 there. And then here we've got lime and cranberry. So that's hundreds and tens. So 4, 4, boom. Okay. Next up is Cape Cod, 4 vodka, and 4 cranberry. Cranberry, yeah, so just 40. Alrighty. We've got gimlet is 6 gin, so that's 60, and 1 lime, okay, and 1 lime is 100. Then we've got gin martini is 6 gin as well, so that's 60, and 1 ounce of dry vermouth, so boom. Oh, 1 ounce. Whoa. Hello. That's 2. Yeah, okay. Let's make sure I got this right. 1 dry vermouth, 1 ounce, so that's actually a 2. The 6, 4, yeah, 4, 4, 4, and then 1 lime mix. Where did I get the lime mix, huh? Where's that? Wait a sec. Okay, this is 300. That's it. 6 and 2 lemon and nothing else. Then we've got 2 ounces of vodka, so that's 400. And then lime and cranberry, which is 1 of each, so that's 2. Yeah, 1 ounce of each. 1 lime, 1 cranberry, so that's 2. Then we've got the Cape Cod here. Cape Cod is 2 ounces of vodka, which is 400. And then 2 ounces of cranberry. Okay, vodka martini. 6 ounces of vodka. 3 ounces of vodka, so that's 6 units. 6 units and 1 ounce of dry vermouth, which is going to be a 2. Okay. Then we've got 3 ounces of gin, so that's 60. Right? Wait. All right, I'm lost again. All right, 1, 2. That's the second drink. That's the third drink. That's the fourth drink. All right, so this one's 600. 600 for the vodka, and then the vermouth is 2. Okay. Now we're here. We got 3 ounces of gin. That one is 60. And then a lime mix. So that's 1 ounce of lime mix. So that's 200. And then the final one, I don't know how we messed that up. That's 3 ounces of gin again and 1 ounce of dry vermouth, which is just 2. So that's 1 drink, 2 drinks, 3 drinks, 4, 5, 6, 7. There are 7 drinks. That is correct. Okay. So let's start with the more complicated piece. We're going to start over here. We are definitely going to need a big one. A big unit here. So this is going to receive an input. So we'll just say it's going to sleep on X0. We'll tie that up. All right. Then it's going to move X0 to the accumulator, or to DAT, I guess. Then we'll move DAT to the accumulator. We've got to get how many units are left. We got to get how many units are left. We got to build the number too, don't we? We might have to do this in 2 steps. So like I'm thinking this one will figure out what to send, and then we're going to need like an intermediate piece that basically sends it. So like we need a little one in here. You're the wrong little one. This is going to be expensive. That's going to send it. And then that one can come in here. That's a pin type mismatch. Okay. So this one's going to sleep on 0, 1, X1. And then it's going to move. Or I guess we'll DST 0, 1. All right, it's 1, 2, 3, so 3, X1. And then we're going to digit set 2, X1. And we're going to digit set 1, X1. And we're going to move accumulator to X0, 1, 2, 3. X0, 0, 1, 2, 3, X3. Yeah, and then that'll basically finish that off. So then this one's job is to receive a signal, and then it's going to create a loop, and we're going to pull the numbers off. Well, I guess we should move X0 to that. All right, so then we're going to pull that number into our working memory. We're going to pull it up into the accumulator, where we're going to pull the numbers off of it. Then we got to subtract one from each one. Well, that's tough. See, that's tough. Like, why is that so tough? That's what I don't understand, right? Why does it have to be so hard? We can't, with digit set, we can't like move it around, which is the really annoying part, actually. Because if we got our, where are you at, conditions? Basic instructions, DGT, isolate the specified digit of the value in the accumulator register and store it in the accumulator register. Set the digit of the accumulator register by the first operand. So, like, we can't do math on the digit. We've got to write to the accumulator, pull the digit off, then do something with it. And yeah, I mean, that's just the way it is. So that's frustrating, because we need to tick them all down by 1. I guess if we do, I wonder what does that look like. So if I pop this out here and I move 1, or let's do 3, 2, 1 into the accumulator, and then we sub 111. What are we looking at? Let's just do that a couple times. 111 sub 111. That's probably not going to give me what I want. Yeah, that changes completely. Yeah, I don't know why I thought that was going to be. I don't know why I thought that was going to be smart. It was not smart. It was not smart. Yeah, it's basically like we want to build up a number that's like I guess we want to build up this number and then subtract it. Yeah? That's great. Yeah, move that to x3 and then move that to 0, 1, x1. Yeah, send that back to us. Okay. And then we can sub that from the final data. Okay, so move data to account. We're going to digit get. We're going to get the third digit. And we're going to move accumulator to x 0, 1, 2, 3, x3. Okay. Then we're going to move mat to accumulator. We're going to digit get the second digit. We're going to move, or I should say, it needs to be 1. It needs to be 0. I mean, it needs to be 1. So I guess greater than 0. If it's greater than 0, accumulator is greater than 0. We're going to move 1 to accumulator to x3, or we're going to move 0 to x3. Oh boy, do we not have enough? Do we not have enough? We definitely don't have enough, because we're going to have to do these 4 tests, these 5 lines 3 times. 3 times, yeah, see, and then I've got 2 more. That is not cool. That is not cool. So it's like I need to set over here probably like test greater than x1 is greater than 0, dst3 1. So like move 0 to the accumulator, and then test greater than x0, x1 is greater than 0. Then we're gonna dst to 1. And then we need to do it again. So basically this one is gonna just need to be a big unit anyways. So we're gonna pull you out there so we can plop that right there. Okay, that stinks. And then we've got another test greater than x1 0 dst 1 1. All right, now we got that. So then we'll move accumulator to x0 1 2 3 x3, and then we'll move accumulator to x1. So we've got all that. So we don't have to worry about all this nonsense. We just have to load, get the digit, move accumulator 0 1 2 3 to x3, move that accumulator digit 2, move accumulator x3, move that accumulator digit 1, move accumulator x3, move that accumulator. I don't have enough code to jump either. That stinks. That stinks. Yeah, yeah. All right, so we got move accumulator x3. Okay. Oh, hey, Alexi. Sorry I didn't see you pop in. Sorry I did not see you pop in. Hope you're having a good evening. Yeah, so we've got 2 lines of code left, and we need to jump back up, and we need to do some writing. Like here, I need to move dat to the accumulator, and I need to sub x3, and then I need to write that back down into dat. So like I need to offload this loop somehow, so that I can like do this loop in one unit. And it's like, I can't have a counter. But I guess I could have something else, some loop control, but then I'm starting to run out of space. I'm already starting to run out of space. So we're going to start moving some stuff over. Because we've got to have 2 of these units on here. What do we got? We need like a loop controller. So you're kind of the loop controller. So I guess maybe you get the signal. Maybe you go there. Yeah. Okay. And then like, I don't want a P1. I want an X, right? Okay, gotta go here. So this is like the loop controller. So this one will sleep on, we'll just say X0. And then it'll move 3 into the accumulator. And it'll move accumulator to X2. And then we will move, we'll sub 1, test greater than 0. Is the accumulator greater than 0? If it is greater than 0, we'll jump back to the loop. When we're out of the loop, we'll move 0 to x2. So I guess just test if it's greater than -1. Then we can get rid of that. And then we're done with this. So now we can put, we're sleeping on x1. It needs to move x0 to x1. To x2, actually. x0 to x2. Then we're going to move x1 to dat. And then for each loop counter, we're going to move dat to the accumulator. Then we need to take the digit and we need to test the digit. So I guess we're going to have to move it. Move accumulator x2. We're going to have to move it twice. So that way we can say x1. Then we don't need all that. Then we need to move the accumulator to x3. Then we need to test greater than 0. Is it greater than 0? Yeah, greater than 0. Is x1 greater than 0? Okay, yeah. If x1's greater than 0, we're going to jump back to the loop. So it'll be 3, 3. And then 2, 2. And then 1, 1. And so once it hits 0, we'll break out. We'll move x1. Well, actually, we want to break out earlier now because we write twice. We're going to move 0 to x2. Yeah. So we're going to move x1 to null. Then we're going to move dat to the accumulator. And we're going to move accumulator to dat. So I guess we should test equal or test greater than. If the accumulator is greater than 0, then we move accumulator to dat and we jump loop. Otherwise we jump sleep. And that's our sleep. Okay. Boom, boom, boom. That's 3 units per piece though. Like, that is a lot of components. That is a lot of components, and they're basically identical. So we need another one of these. I can just plug in there. See what I mean by we're like running out of space, because we still need a unit up here. I guess we can plop that over there. Gives us a little bit of room. We could put a unit like there. But it then doesn't have what it needs to have. It needs 1x to communicate on. So maybe this one here. This one can send, pull it out here so we can use all of our X's. Oh, I could bridge that. I could just bridge that. Okay, cool, because that'll save some room for wiring. So we can bridge that. That'll let us pull this up here, and we can communicate here. We're going to link that up. And then x3 can go to x1 and x2 can go to x1. Okay, so now you're sleeping on x1. And this one over here is sleeping on x1. Oh, it's sleeping on x1, and it's writing to... We can make it write to x3. That's fine. Because that should keep that the same. That should keep that the same. Okay, so now this needs to read a number, send it to here to get the 2 data points, and send the data points in there. That's really all it needs to do. So we're going to sleep on X1. Then we're going to move X1 to the accumulator. Mol 2, right? So 0, and then 1 is going to be 2, so 0, 1, 2. And then 2 is going to be 4, 0, 1, 2, 3, 4. Yeah, okay. And then we're going to move accumulator to X0. Then we're going to move X0 to X3. We're going to move X0 to X2. So we are going to sleep on X3. Oh, this one. Oh, no. Oh, no. It needs an extra line of code. Crud. Okay. Yeah, we need to sleep 1 unit while it's dispensing before we restart. So what can we do? We can move X1 to DAT. Move DAT to the accumulator, get the digit. Move the accumulator to X3. Then we test if X0 is greater than, if X1 is greater than 0, because it's going to be 3, 2, 1, and then 0. So once it's 0, we pop out. We already tested it, right? So that should consume it. That should consume it. So that gives us that. We need to sleep for 1 unit. Okay. That's modified code there. Okay. Okay, up here. All right, so we're sleeping on X3. We move X3 to, what do we got? This is our address is X1. X3 to X1. Then we move X0 to X3. And we move X0 to X3. Okay, let's see where we're at. All right, we got a 4. It woke up. We send an 8 over. It writes an 8 into the address reader. It reads 600. It reads 2. That reads 600. That all does some work to figure out what we need to do. That goes over there. We're outputting vodka. What's going on? Who's not? Okay, none of these are sleeping. Why aren't they sleeping? This is test greater than X0, X1, 0, X1, 0, X1, 0. Why are we writing more to it than that? Okay. Let us get to this point there. Okay, so we read 6 in. We get the first digit, the third digit, and we move that over X3. So that puts 0 into the accumulator. Test greater than X1. It's not. But our digit get doesn't seem to be working because it should be, that should be returning. That should be returning values for us. I just realized I'm like super dark, aren't I? Maybe I should turn a light on. How do I look now? Let's see. Let's pop open this. Yep, okay. We'll turn a light on. Can't really see the light because of the cutout anyways. Alrighty. Back to looking up instruction information. We want to know about this digit get. Isolate the specified digit in the accumulator. So, there we go. Digit 0, 1, 2. We are off by 1 on our digits. 0, 1, and 2. So we need to send 2 to the accumulator. And while it is greater than -1, And so this one will be greater than -1. There we go. That should do it. We run that simulator. We've got 6. Now we should be getting a 6. We send 6 over the wire. Then we send that. Okay. That did not help. Is 6 greater than 0? That should be true. That should be true. Why is that not true? So we should be moving 6 over. It's not showing me what value that was. Oh, okay. But 2, 1, 0. Okay. There we go. Simulate up there. Okay, we send 6 over. There we go. Now we're looking good. That should be 0. That should be 0. Then we move 100 back. We subtract 100. Okay, what did we do wrong? Wait a sec. All right, we're sending 100. Why is it? What is going on? What values are we sending? We're sending 2. 1. 1. Then we send 0. Then we're -1. Aha. We need to send -1. And this needs to be copied over here. This one needs to, whoop, no. This one needs to be copied down here. I love but hate duplication at this point. All right, parts not, why are you not sleeping? What is the logic problem here? Goodness gracious. This is very frustrating. Where are we at? I want to get to, let me get to this point here. Right, all right, simulate that. All right, we are here. And you're up here, which is not right. So we basically, maybe we don't need this. And we can remove this, and we can just move accumulator to x2. Maybe we do it that way. Oh, wait, boom. Okay, so simulate. Right. Okay. This is good though. Because we're not done yet, as a matter of fact, this needs to sleep on x1. Yep. And then it jumps to the loop. Yes, so what we actually need to do here we don't have enough code. Because we need to like move it over here, and then that needs to write it back. This needs to do the sleeping part. So what we can do is, instead of, we can save some lines here. We're gonna have to move these into a big unit, which is, I don't like it, but it is what it is. Okay, so we've got, we don't need that. We can have this come up here to x0. What pin is not connected? That pin's not connected. Okay. Okay. Chill out. Go back up there. Yep. Wire that back up. Okay. That'll quiet that for now. So X2 needs to become X3. X3. Okay, so we get the value on X0. And then we move that to X3. We move that to DAT. We move DAT. And then we need to enter our loop, our main loop. Where we move DAT to X0, 1, 2, 3. Yeah, so X3. Then we move 2 into the accumulator. And we move the accumulator to X3. We subtract 1 from it. We move the accumulator to X3. We do that. That jumps to the loop. When we're out of the loop, we need to move DAT into the accumulator. We sub X3. We move the accumulator into DAT. Actually, we test greater than 0. And then we move accumulator into DAT. And we jump main loop. Otherwise, it'll jump back up to sleep. This needs to sleep for 1 unit. I'm missing the sleep for 1 unit. So where are we at here? Sleep X0. Move X0 into DAT. Move DAT to X3. Move 2 into the accumulator. Move the accumulator to X3. Subtract 1. Move the accumulator to X3 again. Yeah, because it's got to test it. It's got to test it. It's got to test it. So what if I send move accumulator to X3 sub 1, right? And then I don't want to send that. Then we move DAT to X3. So we send DAT to X3. Move DAT to X3, move accumulator to X3. Then we subtract 1. We test greater than -1. We jump L. Then when we get out, we're out of it. Okay, let's see how that changes this. So this is gonna sleep on X1. Once it gets a signal on X1, which is move DAT to X3. We don't need that. We're moving 2 into the accumulator. And then we move DAT to X3. We move the accumulator to X3. Then we get here to this point where we move DAT to the accumulator. We subtract X3. If that's greater than 0, we move the accumulator to DAT. We sleep for 1 unit, and then we jump to main loop. Otherwise, we'll cycle back around and we'll sleep on X0. Okay. So this is going to sleep on X1. Once we get a reading on X1, we start. We don't need that anymore. We start our loop where we move X1 to the accumulator. The first thing it's going to write is DAT. Yeah. We move X1 to the accumulator. Then we move X1 to DAT. Let's just rewrite this all. Then we get the digit of dat, and we move the accumulator to x3. Then we test greater than dat is -1. We jump to loop. When we break out of the loop, we move x3 to x1. And that's it. That's it. That's all that needs. Can that fit on a small one? This is 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of code. 1, 2, 3, 4, 5, 6, 7, 8. 8. Yes. No, because we use dat. Because we use dat. That's why it doesn't work out. Okay. And then this one's complicated. Okay, so this one we can move this logic. This will need to come and live in a component over here. Whoop. Oh yeah, we're copying that over. This will come over here. Okay, now we can't do x0, but we can do x1. Everything else is good. Okay, so let's step on it. We advance there. We get 600. We send 6 there. That sends it over. That gives breaks our digits down. That gives us our output. Why is it still jumping the loop? Oh my god. Okay, so move the accumulator first. Move it first. So we're gonna move x1 at first. We're gonna move it into dat. Then we're gonna test greater than dat -1. If it's not, we jump out. And then we move x1 to the accumulator, digit dat, move the accumulator to x3. We don't do that anymore. That's not conditional anymore. You are out now. Okay. Let's see if that works. We go through. I want to get to this point. Yes. We don't. We don't ever get to that point. Test accumulator is greater than 0. But that means when it hits 0, it won't be there. We need it to be greater than 0. So we send it. Okay, come on, let's get in here. Okay. So we move accumulator to x3. That moves it into dat. It's greater than -1. Oh, it jumps out. That's the problem. There we go. Okay. What? When do I get there? Never, because why? Because because you don't get a 3. Okay. So maybe I just test equal if dat is 0. Boom. If it's not 0, boom. So it is 0. We're out. We now move that over. We subtract that. That sleeps for 1 unit. Who's not sleeping? These aren't sleeping. Why? Oh, because I don't have the updated code. So we're updating X1. This logic here. Okay. So we can advance now. We actually don't need this out label anymore. Get rid of the out label. Yeah, we don't need that out label. Why didn't we turn off? Why didn't we turn off? Oh, we're not executing an off signal. We are not executing an off signal. Schnapps. Yeah. That jumps back up to the main loop. Otherwise, it goes back up there to sleep X0. So we need one more iteration to zero things out at the end. All right. So I guess what we'll do is we'll test test equal. If the accumulator is equal to 0, then we're going to move 1 to the to X1. Otherwise, we move that. And then over here, where we test if it's greater than -1. So that should run our logic for a little bit longer. Still didn't work. Why are we getting weird numbers here? What in the world is going on here? This weirdness is... Okay, so we get a 4. So let's even see if that's right? Like, it reads the right numbers out, right? 4 points to 600. So if we go back to our reference card and we do the Elegant Bachelor, 0, 1, 2, 3, 4. That's a vodka martini. Is that right? That is wrong. We're getting the wrong drink. Yeah, we need to sub 1. Okay. Now we get our 4 here. We get a 6. We send that up. That is 400, which is drink number 4. 1, 2, 3, 4. That's our Cape Cod. So that should be 2 ounces of vodka and 2 ounces of cranberry mix. So that sends 2 up there. And that goes, and that turns off, and then that goes. Ooh, did we do it? I know we're going to be super high on code and we're going to be super high on cost, which means we're going to be high on power. Oh, yeah, we've blown all of the numbers off the charts. Look at our power usage. I guess there's a lot at 4K. We're less than 4K, so that's good. But yeah, we've got tons. All right, let's look this one up. I want to see this one. Somebody needs to show me. So we're gonna do Shenzhen I. What level is this? Airline cocktail mixer. Yeah. I don't know how we're gonna do this one. Very simple, but we'll figure it out. This one, I mean, it's still pretty complicated. They tried to use some power there. They tried a lot of different things. None of those seem to be like an optimal solution. That's just the description. Okay. This is ridiculous. Yeah, this is a ridiculous solution. All right, so we got one big one that is right there, 3 units away. Okay, so it sleeps on X0. Move X0 to accumulator. Test equal accumulator 1. Gen P130. Move accumulator X1. Test equal accumulator 2. Test equal accumulator 5. Gen P160. Test equal accumulator 3. Test equal accumulator 4. Gen P140. Test greater than accumulator 5. Gen P060. Okay, P1 goes right into vodka. P0 goes right into gin. This goes right up into X0. We've got another big one. I don't know why they're placed at 3, 6 here. Okay, so this X0 comes, I don't know why it's so long. I don't think it needs to be that long. We've got sleep on X0. Move X0 to accumulator. Test equal accumulator 2. Move 100 to X3. Test equal accumulator 3. Move 11 to X3. Test equal accumulator 4. Move 1 to X3. Sleep 2. Nice random sleep 2. Accumulator 6. Move 10 X3. Move accumulator X2. Sleep for 2 again. Move 0 to X3. All right, let's wire this up. We need to put this goes here. This wires up to lemon, lime, cranberry. And then we've got a small unit here. Nope, that's supposed to be one with the P. Port which goes there. X2 goes there. X3 goes there. And then this unit sleeps on X0. Move X0 to the accumulator. Test equal accumulator 5. Test equal accumulator 7. Gen P120. So I think they're abusing 5 and 7, vodka martini and gin martini. So if we look that one up, wrong button. Vodka martini has 2 of vermouth. Yeah, this is plugged into vermouth, and 7 has 2 of vermouth. So this one's kind of abusing the fact. So if this runs and it's not equal to 5, then this one will run. And if it is equal to 7, this one will run. If this is equal to 5, this is ignored, and this will run. So both of these trigger this line. So we're kind of abusing that. I have a feeling this is just going to be like a straightforward, coded out simply. Mine is very dynamic. But yeah, this is a very elegant solution. It does work very well. Yeah, very well. Cool. Puts mine to shame. I mean, this is ridiculous. That one uses 200 power. But the benefit here, even though it's bad, is that we could easily just like change this to be like 333. And so now it's going to be wrong. But if we ran it, where we get, we need a 1. Let's put a breakpoint there, right? So we get to the point where we hit a 1. Then we just run those 3 units, right? Like that's all it takes to update this. So it's a little bit more dynamic. It's a lot more code. Yes, that's just how I work in this unit. I'm not very good with the embedded systems here. Need to learn how to break problems down into a hacky way, plugging all these interfaces together. What is this? 1, 2, 3, 4, 5, 6, 7, 8. We do still use dat. Yeah, that's why we didn't replace it. Okay. Yeah. So cool. We did that. I wanted to say thanks for sticking with me. Hit the wrong button. Okay. The big one. Here we go. The job we get finally came in, and it came specifically for us. Sun Haotian himself. He's calling it the safety net tracking badge. Looking at the specs, it seems to have multiple functions, including reporting the location of the wearer around multiple sectors. There's a map included. I don't think I can overstate how important this is, so yeah, here we go. We got a radar sync, radar ping, and we got a speaker. This is the big one. Wow, look at that. And then we have the grid. So I know, yeah, we do have a sector map. Okay, yeah, let's see. Radar sync is a simple input indicating the current heading of the central tracking radar. Radar ping is a simple input indicating the current distance from the central tracking radar. Right? Radar ping is a simple input indicating the current distance from the central tracking radar if it is currently pointing in the user's direction. A simple input indicating the current heading. Radio RX is a non-blocking X-bus connected to a radio receiver. Radio TX is an X-bus output connected to a radio transmitter. Simple output connected to a miniature self-amplified audio speaker. When a data packet is received and begins with the value of 1, the subsequent data should be treated as length prefixed audio data and played over the speaker. When a data packet is received that begins with a value of 2 and specifies the ID of the badge should respond with its current sector. The user's location can be determined when a radar ping pulse is detected by correlating the current heading and distance from the central tracking radar with the sector map. Correlating the current heading and distance. So we've got to like encode these sectors. What are their distances? Hey, where are we at? Sector map. So they go up in units of 20. I don't like the way this looks. This looks fairly complicated in determining locations. So let's kind of see 2558. And we send back 202. which is this sector. So we got a radar ping value of 67, and radar sync is 60. Okay, so that one's only in units of... Wait. What is it? Radar ping is a simple input indicating the current distance from the central tracking radar if it is currently pointing in the user's direction. So this will basically log the distance, and this is the simple input. So we have a distance of 67 at 60. At 60. So a distance of 67 at 60. Ping greater than 50 is this outer ring. So yeah, sync is always 0, 20, 40. Okay, so that's pretty simple. Then we just have 200, 201, 202, 203, 204. Ping greater than... Oh, ping less than 50 is the outer ring. Ping greater than 80 is the inner ring. So I think these two will kind of be their own thing. And we'll just like request the data from it to send it out on a 2. If we get this number, we just need to send them straight to the speaker, basically. Yeah. 558. So that must be what number we are. Yeah. Okay, so I guess let's work on numeric output first, right? Let's work on numeric output first. So we receive on that. We'll put that over there because we don't need it. So we're gonna do audio output first. So this will be... No, we do need that. We receive here. So we're gonna move x0 to the accumulator. Test equal accumulator 1. Then we're gonna jump audio. Or we'll just do AU. And we'll have AU here. AU's gonna move. How many units is it? I mean, it's basically until it receives negative 999. So we're gonna move x0 into the accumulator. Test if it's greater than negative 999, or I guess if it's equal to negative 999, then we jump to sleep. Jump AU, and then if it's not, we're gonna move that to P1. And then we're going to move 0 to P1. We're going to 0 that out. And we're already out of space, so we're going to drop this in here. And we're going to do that. Sleep for 1. Let's see if we can get away with this sleep at the beginning. So we have like a... I mean, does it matter if it's at the beginning or the end? It doesn't matter. Sleep for 1 unit. Yes. Okay. And if it is a 2, jump. Or I guess we'll move 0 over like x1, and then we'll jump to sleep. Boom. Oh, it needs to move x0 to x1. We need to put a bridge there so we can get that out. Move. Great. So that'll be that. That covers audio, right? So if we have the audio come in. Great. This is expecting a signal of 50. Okay. Move 50 P1. And then what we got? We got move 50 is our baseline. Audio is weird in this one. All right, so we get... Hey now, what do we got? Move x0 to the accumulator. Move the accumulator to P1. What do we got here? Ooh. Wait, yeah. Okay. It's a 1. We jump to audio. We move it to the accumulator. We move that to P1. We're not pausing in our audio loop. Yeah, our audio loop. We need to pause in the audio loop. So we need something that writes to the audio output. Let's move everything over 1. Boom, boom. Hello. Put that there. Put that there. Then this can go here, so that can go there. Move accumulator to x3. x3. So we're gonna sleep on x0. We're gonna move x0 to P1, and we will at move 50 to P1. We don't need that anymore. All right, so we read that in. Before we jump, we need to sleep for 1 unit. Why are you writing 0? Why is it not? It's supposed to be jumping. All right. If it's not equal to -9, if it's equal to -999, let's start there. If it's equal to -9999, we jump to sleep. Otherwise, we sleep for 1. And then we jump back to AU. And this goes up here, where we move that. Oh, and then we've got our jump to AU. Okay. I think we had our loops kind of all wonky. All right. We jump to sleep. Why should we? Why do we? Oh, wait. No. Move 0. That's 12. It is when it is equal. Gosh, I'm just going really, really wild over here, messing this stuff up. I tell you what. All right, it's still not working. That is still not working. All right, we got a 12. We move a 12 in there. We move a 31 in there. Okay, we are never moving. We're never moving. Move accumulator to X3. Yeah. That updated us to 12. It expected 31. How does it get 31? Connected to a miniature self amplitude. So like, oh, that's the freaking okay. All right. That's our loop right there. Then we're gonna move X0 into the accumulator. Then we're gonna jump AU, where we move X0 to X3. And then we sub 1, test greater than 0. If accumulator is still greater than 0, we jump AU. Then we move 50 to X3. There we go. Yeah, so we didn't actually need to write 12. 12 is how many units we have to read. I think this was supposed to put this sleep 1 over here, but actually I don't need that. We can get rid of that now. And we can plug that up. So we're moving it to P1. We're moving that to P1. And we need to sleep 1 in between. No, we don't. Yeah, we can do that. Yes, we can do that. But we're not initializing to 0. We don't have the initialize anymore. So if it's equal to 1, we move it in the accumulator. We jump AU. That could be, we could move that. Jump AU. Yeah, I mean, we could put sleep up here. And then we could put move Move 50 to P1, sleep for 1. Does that. That resets too soon. Alright, if I put sleep here. Yeah. Yeah. It's just not working. Okay, we need sleep 1. Move 50 to P1. So we need to initialize this to 50. That kind of needs to happen first. What can we reduce? What can we reduce? So if it's 1, we need to move that into the accumulator and jump to AU. If it's equal to 2, we need to move that to X0, which will send its own signal back. Because it'll send that ID over. And we jump to SL. In both cases, we're moving a value into the accumulator. So if we just read both values first, yeah, because we're always going to get 2 values. So we're going to move that into the accumulator second. We're going to move that one into DAT. Okay. No. That one goes into DAT. That one goes in the accumulator. There we go. Then we can test DAT. Then we can test DAT. All right, perfect. That's going to jump AU. And that's going to move the accumulator to X1. I'm in the same lines of code. Yep, same lines of code. Don't know why I thought that would be different. I don't know why I thought that would be different. If I put this sleep up here, I can remove that jump line. So like that. And then that would jump start. So that doesn't really do anything. I don't know why I thought that did. Don't know why I did. Okay. I'm trying to do all this just to avoid sending it. I can't avoid sending it. I'm just going to send it. This is sending over X3. This is sending over X3. Put it there then. And we'll just move 50 to P1. We'll sleep on X0. We'll move X0 to P1. And that's it. I mean, I don't like doing that, but that gets us our values too soon. What if I just swap those like that? Was that it? Okay, that seemed to have been it. All right, let's put this down. Let's pull this down. I don't know why I had it wired up that way. So we can pull this bridge off. Pull this bridge off. And we can wire into X1. So this is an X1 now. Move accumulator to X0. Okay, we need our data ping. So we'll probably write it in there. So basically, every time we get a hit, every time ping is greater than 0, that's our distance, and then that's where we're facing. Yeah, so minus 20. It's minus 20. It'd be great if I had like 1, 2, 0, 1, 2, 3, 4, 5. And then it wraps back around to 0. We could do that. Or we keep an accumulator. That gives us 0, 1, 2, 3, 4, 5. But then we've got another lookup on top of that. So we got to know the ping, basically. Ping is 53. Heading is 60. So ping of... let's go back to our map over here that has the data. So ping greater than 80, ping less than 50. So if it's between 50 and 80... All right, so let's do that first. So we are going to move, well, we have 0 in there already. Okay. So each loop, we're going to pull this down so we can have this come, like, can come in there, and then radar ping can go there. Okay. So each loop, this is going to move, or it's going to test equal, test greater than 0, P0. If P0 is greater than 0, so I guess if it's not, then we'll jump to sleep because we don't know where we're at. And when we sleep, we add 1 to accumulator, add 1, test greater than accumulator 5, move 0 to the accumulator. Okay, I hope this doesn't have to do a whole lot of work. Because we'll see where we're at. Okay, if it's greater than 0, the ping is greater than 0, then we know where we're at. Yep, we know where we're at. So that starts 0, 1, 2, 3, 4, 5, and then when it's 6, it'll reset back to 0. We can just cheat it that way because that's how it's going to be. If it's less than 50, it's 700 unless we're 0. So how do we do that? Test equal Yeah. Can we store? We've got 1, 2, 3, 4, 1, 2, 3. We've got 6 and 3 values. We really only need 2 values for 6. So maybe we just have a lookup table. I mean, is it overkill? Yes. But I'm going to do it anyways. So 0 is either going to be 1 or 2. So that's 600. 600. And then for 1, we have 700 and 200. For 40, we have 700, 201. Actually, those are special cases. We may not need the lookup table. I think we've got a good hack here. Yeah, I think we've got a good hack here. So we've got some special cases. Let's handle the special cases first. This needs to push data in there. So what we'll do is we'll move P0 to X3, and then we'll move P1 to X3. So that'll go out to a sleeping unit over here. This wonderful sleeping unit over here that has to be wired up to that. Does it have to be wired? It does not. It does not have to be wired up that specifically. So we can pop this back. So we can have X2 can go to data, and address can go to X3. Yeah, it just needs to write into there. I don't think we can save any room by moving those under. We may have to move these pieces around, though. Theoretically, I could move this under here. We could pull X3 down into X1. Then that X3 could come up there. And we could bridge X2 out there. Then we could clearly move this unit over here. Save some room over there. Okay. So, actually, we can bring this one back. Yeah, we don't need as many exports available on it as we once thought we did. Yeah. That lets us not do anything differently. Actually, I can bring this back once more. And that could come this way. And that hits X3 there. Boom. Up that way, which is beneficial because we can move it back yet again. Gives us a little more room. Okay. So we are going to sleep on X1. What do we need first? We need the distance. Yeah, we need the distance. So test equal X1, is it greater than 80? Or I guess we're going to have to move it. Move it into the accumulator. Test greater than accumulator. Test greater than accumulator 79. Because it says greater than or equal to 80. It's 100. So we're going to move X1 to null. And we're going to move... we should always move 0 into A0. Yes. I mean, I could read that address, sub 1, and write it. Then I could just keep writing the data. Maybe I'll do that. Let's just do that. Let's just not even worry about this address here, right? Then we don't need a bridge. We could just straight up come out there into data. Boom. Yeah. Which means we can call them back one more. Okay. So we move x1 to null, and we move 100 into x3. And then I guess we'll move dump. So DMP will move x1 to null, and then sleep will, and then it'll go but sleep. Okay. So move to dump, that means jump to dump. So if it's greater than 80, it's 700 unless we're sync 0. Oh no, if it's greater than 80, we're 100, period. Doesn't matter what. Then if we're sync 0, so then we test equal x1 to 0. We move 600 to x3, and we jump to sleep. Then it's just a matter of if we're less than 50. So test equal x1 accumulator. You know what, folks? Give me a minute. I need to take a quick break. And we are back. Rock on. All right. Sorry about that break. I just, every once in a while, need to take a break. Okay. I had an idea while I was in break, but we'll see if I need to use it because we've got plenty of space here. So what we're going to do is we're still trying to cover these special cases. So the next special case we have, actually I think we covered it. We moved 600. Then we jump to sleep. So now we're testing. Okay, what are we doing? We tested. We're in sector 0. Hang on. That's our ping. That's our ping limit. That's not move x1 to dat. Let's pull them both in, right? Pull them both in because we need to know if dat is 0. Dat is our index. Right? Ping P0. Ooh, we are writing P0 out. We do not care about P0. We care about, we don't care about sync. Actually, you know what? I don't even need to read from sync. Like, I do not care what sync is. We're going to write our sync value out first. We're going to move accumulator to x3. So we're going to write our sync value first. So accumulator sync, and dat is our ping. So we are looking at dat. Dat is our ping. We don't need to dump anymore. Just straight up jump back to sleep. Yeah, we just read both of them. Then we don't have to worry about that. Jump to... then we test our sector. If our sector is 0. So the special case is 100 is always greater than or equal to 80 ping. I know you can't... Well, you can see the sector map here. So greater than or equal to 80 is always 100 ping. And then if we're in sector 0, it's definitely 600. If we're in sector, or if we're in any other sector, less than 50 ping is 700. So once we're at this point, we need to test less than, is it less than or equal to 50? Yeah, so less than, ping is dat, right? So 51, move 700 to x3, jump sleep. Finally, and this is why I wanted ping in the accumulator, not ping, sector in the accumulator. We add 201. Do we add 201? We add 199. Because sector 20 will be 1, and we want it to be 200. Sector 40 will be 2. So basically we got 0, 1, 2, right? So if it's 1, we add 199, that'll be 200. If it's 2, that adds 201. And then we're just going to move accumulator to x3. Boom. So that should keep track of our location. Let's see how that fares. So we go through there. What happened? We've got our numbers mixed up here. Yeah, move x0, move x1. Yep, all looks good. So we're in sector 202. We're still in sector 202, 53, 63. 0, 1, 2, 3. So, yep, 202. That looks good. We're in sector 202. That's when we need to get our address. So let's go ahead and code that up. That's gonna need 4 exports, but I don't think it needs a lot of code. And we don't need a lot of data. Oh no, it needs 1, 2, 3, 4, 5. Ooh. Nothing has 5 exports. So I guess we're going to have 2 layers here, which sucks to high heaven, but, you know, it is what it is. This will wire up. You can just wire that up like that. All right, so sleep on x1, test equal x1, x3. If it is, we're going to move 0 on x0. That's all it's got to do. This is going to sleep on. All right, we need this address. So we're going to have to pull this down 1 unit. Why don't we just go ahead and pull it down there? Nope. There. Nope. There. That's fine. It should be fine. So we've got that address. We've got that data. We've got this address, and then this will come up here. So we're sleeping on x2. That didn't save us any. We move 0 on x2, and then we move x2. What can we do here? We could raise, can we raise this up? Can we do that there? That's not wired up. That is not wired up. We could put that, we can't put that there. Can we move, we could move this one back. We could move that one back. Okay, so this goes here. That can go there. What did I need? I need access to this one. So can I move this perhaps this way? Can I perhaps move it that way? So then we have, what do we have? X3. X2 is our receive port. So change all of our X1s to X2. We still need to communicate over there. So how do we do that? We can bring this here. I mean, I could move that through, but then that's going to pick up on the transceive. That's not going to work. Now's the fun, now's the puzzle part. We can pull this one up. That gets us X3 can come out. We don't even need X3, that takes up space. We can pull X0 down. We can pull X0 down. We can pull this all the way. No, I can't go all the way. Like right there, but we don't even need to do that. We can just boom right there. You know what? X1 is fine. Doesn't matter. So that goes out X0. X0. This one will write to X3 needs to be data, right? So we can pull this over here. We can write that data. We need a gap. We do still need a gap. We do still need a gap. We can come in. Ooh, but we can actually come in here now. Come in hot right there. And we can write to data. Boom, to data. Alrighty. So this can come over quite a ways. Up to X3. Okay, pin not connected. Let's connect it. Yeah, X2 is the one that we are connecting. This can now come back here. So we can pull this back here. Because we need... pull that up. Yeah, X3 needs to come out and go into X0. Like that. Okay. Can we come out X2 so we can replace X3 with X2s? That lets X3 get used. So we can signal to this unit. It can read on X2. And X3 can go there. And then we can just bridge that down to transmit. So we move X2. Move X3 to X1. All right, we sleep on X0. We move X0 to X3. Then we move... What are we doing here? We test equal x0, x3. X0, x2. Yeah. Is that equal to this number? If it is, we move 0 to x3, and then we move x3 to x1. Otherwise, we just sleep again. And it's that great. And then over here, we sleep on x2. x2, we move x2 to null. We move x0 to accumulator. We sub 1. We move accumulator to x3. And then we move x1 to x2. Yeah. And we're done. All right, we get the that comes in. We get that. That sends 558 over there. It does test it. It sends a 0. That moves, pulls the current address, subtracts 1 from it, writes that, reads that, sends that location to transmit, and we're good. Boom. Oh. What happened there? What happened there? Let's put all right, reset, simulate again. What happened here? Okay, we should be located in 600. Why are we in 199? We should not be in 199. So the last ping, let's put up at those pings and we'll start over. All right, so we're going to simulate up to this point. Okay, we should be in 200. Our current ping, so we're going to step through, move ACCX0. So that moves 1 down there into accumulator, and then we move P0, and it's 67. All right. Is 67 greater than 79? Okay. Are we in sector 0? It's expecting us to be. So we are 67 at 20. This is 20. We're in sector 200. So let's see if we get 200, and that's what we should get. So are we less than 50? We are not less than 50. We add 199. We move that to X2. That writes 200. Bam. Yeah, that's fine. I mean, it's going to be awake every time, which sucks, but what you gonna do? Ooh, actually, I figured something out here. Or I didn't figure it out, but I just thought of something. So we always want to sleep. We always want to sleep here, but then we either jump back to audio or we move. No, we don't want to do that. That's not going to work like I thought. Because then we would end up sleeping twice, and we don't want to sleep twice. Not what we wanted. Oh well. Yeah, it's kind of like each loop we want to sleep once. but we don't really want to do that. I mean, it probably won't be a problem, but I'm not worried about. I'm not worried about min maxing everything. What's going on up here? Why is this one messed up? When did that get deleted? Okay. All right, let's simulate. Let's simulate back where we were. We've got these arrows. Okay. So we're in sector 200. We write that we're in sector 200. Then we go forward. We got another ping. We're now in sector 600. Less than 63. So we send 0 down and 63. Are we greater than 79? Are we in sector 0? Yeah. Wait. Yeah, that ping, that check is wrong. So that's the problem there. That should correctly put us in sector 600. Now, yeah, that puts us in sector 600. We send that over there. That's our location. Then when we get asked what our current location is, we look it up, and it says 600. And then we get asked our location again, and we're still in sector 600. Okay, and that should be it. Bam! Solve every puzzle in the main campaign. We did it. And we actually weren't that bad. Like, we were kind of middle of the pack. We weren't average, but we were middle of the pack here. Power usage, production cost, all of it not too bad. Not too bad. Boom. Oh, we got an invitation. Dear engineer, how would you like a chance to work with world-class peers on top problems facing humanity? Click and hold this button. Object. Decide if you want to join Sunhausen in Avalon City. Oh no, is there more game or is this just post-game? It does say main campaign. But so what did I accomplish in Shenzhen? Engineering stories aren't like movie stories. I didn't find love or save the world or anything like that. But it brought me here. To the start of something new. Maybe something good or maybe a disaster. But no matter what the future holds, there's one thing I know. One thing I can always count on. I'm a damn good engineer. I mean, some of those solutions were dog shit, but what can you say, right? Shenzhen I, a game by Zachtronics. That was a lot of fun. That really was a ton of fun. The puzzles were challenging. The spatial aspect really adds a whole new layer of like problem solving. Because it's not just about code anymore or how much code you can fit. I mean, with like TIS, you have a limited amount of space on each node. But you have multiple nodes, and they can all communicate in multiple directions, and they have their own accumulator. So it's really easy to like kind of code in functions. But with Shenzhen, your instruction set is limited. Like you don't have, I don't think you had division in TIS either. But yeah, it was a tough one. But like compared to Exapunks, right? Compared to Exapunks, wow. That one just kind of gives you the freedom to write whatever code you want. I mean, the language is very simple.